Hi, everybody. It's Friday, April 17th. Today, we're going to start our discussion of adding and subtracting rational expressions. 5 out of 4 people agree fractions are important. Oh, Ron Burgundy, you really are something. All right, so let's warm up. If we wanted to add 2/3 plus 5/6, what would we do first? Figure out the common denominator. What's the least common multiple of 3 and 6? 6. So to turn that first fraction into something with a denominator of 6, I'm going to multiply it by name of 1 or 2 over 2. So 2 times 2 gives me 4, 3 times 2 gives me 6. So now I'm looking at 4/6 plus 5/6, which would be 9/6, reduces down to 3 over 2. All right, so of course it's not going to be that easy. Now we're going to put some numbers and letters and exponents, all of it together. Follow these 4 steps and you'll be good to go. Step 1, factor and cancel. Step 2, can we find a common denominator? Step 3, multiply each fraction by whatever it takes to make that common denominator in both fractions. And then finally, we'll distribute, combine like terms, do what we have to do, adding across the top and keeping that same denominator. So look over here on the right. I'm going to take 2 over 6b to the third and add it to 6a over 3b. As you can see, I broke apart the 6b to the third. I can cancel out a 2. As you can see, I also broke apart 6a over 3b. I was able to cancel a set of 3's. Now, my common denominator in step 2 would be the common multiple of 3 and 1, which is 3. And then, an easy way to think about it is what's the largest number of b's that you have there in the denominator? B to the third. So our common denominator, CD, will be 3b to the third. First fraction is good to go as far as the common denominator goes. The second fraction, I need to multiply by 3, and then I need to multiply by 2 more b's to make that read 3b to the third in the denominator. Now in step 4, I kind of just, did some of this work maybe in my head. I wrote the common denominator as 3b to the third, and then reading across the numerator, the tops, 1 plus 2 times 3 is 6, a, and then b squared. So that's my first answer for my first problem. Let's try another one. All right, now what makes this one different is that we have a binomial denominator, and you can see here I put a set of parentheses around that binomial denominator. So that's a done deal. That's a package. You can't break those apart. That's kind of set in stone. Do not, and I repeat, do not cancel the 3's right here. No, no, no. Don't cancel those n's. No, no, no. The only thing that you could cancel is if you had a numerator of n plus 3 and you could set it or you could put a set of parentheses around it. Sure, then go ahead and cancel, but don't break apart this addition in order to cancel the 3 or the n. Over here on the right hand side, 6 over 4 I reduced down to 3 over 2. All right, what will our common denominator be? Well, like I said, that n plus 3 is a package deal. We're stuck with it. And then I'll just slap the 2n on the front. So level things out now. I need to multiply my first fraction by 2n. I need to multiply my second fraction by n plus 3. So that's step 3. Multiply each fraction by whatever it takes to make the common denominator. Now step 4, distribute and combine the like terms. So on top here, 3 times 2 is 6, n squared. And then here I'm distributing 3n plus 9. If I could have added any of those together, if they were like terms, I would have done that. But in this problem, I think we're good to go. Now, don't worry about factoring this numerator. I don't think it will factor. I'm not going to take the time to think about it, but it's good to go. Just leave it like that. All right, here's another one. Now, this problem is actually subtraction. So I am subtracting all of these things. I'm not just subtracting the first thing I come to. So what I like to do is put that whole second fraction in a set of brackets. That reminds me, when I'm all done, I need to subtract everything. Okay, but maybe step 1 will, kind of simplify this for me. Can I factor anything and cancel? Well, in this denominator, I could pull out a 2 and an r. That leaves me with r plus 2. Look at that again. Factor out a 2r, I'm left with r plus 2. Yep. Okay, that's r plus 2 is wrapped in a set of parentheses. I could throw r plus 2 in the numerator in a set of parentheses, and then those puppies would cancel. What's my problem now? Well, it's 5 over 3 minus 1 over 2r. All right, step 2, common denominator, pretty straightforward, 6r. Step 3, level it out, 10r over 6r minus 3 over 6r. See what I did there? I just multiplied by whatever I needed to in order to make that denominator a 6r in each separate fraction. All right, step 4, distribute. Combine like terms. Do what you got to do, yo. 10r minus 3 all over 6r. All right, example number 4. Oh boy, we have two binomials and it's subtraction again. Like I said, throw this in a set of brackets and that will, that will prevent you from making a sign mistake, a sign error. Step 2, common denominator. Well, should I have factored and canceled first? No. I know it's tempting to cancel those x's, cancel these x's, but remember, if you have a binomial, the only thing you can cancel with it is that same binomial if it were on the other side of the division bar. Nothing cancels out, so my common denominator actually is going to be both of those binomials kind of multiplied together. So here's my self-leveling, make it work so they both have the common denominator. 2x plus 1 times 2x plus 1 minus, I've kept that in brackets because I'm going to have to distribute in that negative. I'm going to have to subtract all of those terms. All right, so my common denominators match. Now step 4, distribute, combine like terms. So I distributed in the 4x and I got 8x squared plus 4x. I'm gonna stick with that set of brackets for right now and FOIL. Hey, FOIL, good to see ya. 3x squared minus 5x minus 9x plus 15. Now distribute in the negative. So this is what I'm doing down here. Pushing that negative in changes all of those signs. Yep, combine your like terms. And there we go. That's our final answer. Now, I didn't spend a whole lot of time talking through that. If you want to pause the video right now, that would be good. Digest this. Catch up in your notes. Hopefully, you're taking some good notes. I'm going to go on to our last example. Here we go. Example 5. Wait a minute. 4x isn't a rational expression. It's just a numerator. Well, you can turn it into a rational expression. Give it a denominator. I'm subtracting again. Check out my brackets. Whoa, x squared plus 9x plus 20, that's a trinomial. Luckily for us, it's a plain trinomial, so, kind of think through what are two numbers that will multiply to 20 but add up to 9? X plus 5s. All right, those binomials exist as identically in the numerator and in the denominator. And this is what I'm left with. Common denominator of x plus 4. Level her out here in step 3. Make sure both rational expressions have that common denominator. One is just going to kind of turn into invisible. It's going to put on its invisible cloak here in a minute. So I'm not going to multiply both sides over here. I'm not going to multiply the second fraction top and bottom by 1. 1 times 1 is 1. 1 times x plus 4 is just x plus 4. And then check out how I got to my final answer. Distributive property. 4x squared plus 16x minus my other numerator, which was a 1, and I'm left with x plus 4. So, if you were really in the mood to do some more factoring, you could try and factor this numerator. I'm going to tell you right now, nothing's really going to factor, so just leave her alone. All right, so that takes care of that. What I would like you to do is go back to the Google Classroom. I've got a little Google form type quiz for you. And then have a great weekend. Can you believe this? Snow on Friday morning. Where are you, spring? All right, have a great weekend, guys. Bye.